Well, my PM-30 mill just arrived 2 days ago, and the rigger installed it yesterday. This was an order for 3 months. I ordered it back in September, and here it's December 31st, and I'm just installing it. So it took a while to get it. Apparently it was tied up in the West Coast out in one of the ships for quite a while. And now I'm ready to finish the conversion to convert this to a CNC system. Now, I did buy my conversion kit from Arizona CNC, and the parts came in. I'm ready to install it. I have a few concerns about doing this. Number one is the weight, because I have nobody to help me do this, so lifting this table may be an issue. And the other concern is, milling the slot's going to have to be milled in the table to get one of the ball screws to fit. So we'll see how that goes. This is the first time I've done it. Probably be the last time I do it, so I'll be learning as I continue with this disassembly and refitting it back together. So let me start by disassembling the system, and we'll see how it goes. The PM-30 CNC conversion kit used for this conversion was obtained from Arizona CNC. I want to give a special thanks to Dave Clemens from Arizona CNC, who was very helpful in giving me some advice on the installation, alignment, and problem solving during this installation. I also want to thank Stephen McEwen from DMM Technologies, who also gave me some pointers on the installation of the DYN4 servo motors used for this conversion. I encountered a few issues which I'll describe in this video, and both these individuals were helpful in resolving my problems. In addition, I posted some questions to the Centroid user forum and was answered back with a response to my questions in a timely manner. The total disassembly time was almost 3 hours, which was much longer than I'd anticipated. This was the first time I had done this procedure. Therefore, much of that time was due to my running around, finding the right and correct tools that I needed for the job. I began disassembly by removing the two bellows and way covers. Next, I removed the handle from the right side of the X table, using a socket wrench to remove the screw holding the handle to the shaft, and then I removed the pin from the shaft. Next, I removed the 4 screws on the lead screw bracket. Breaking the lead screw bracket from the X table took a little work. First, I tried locking the X table and turning the handle on the left side of the table to try and break this joint. This did not work. What finally worked for me was using a small rubber mallet and tapping the lead screw bracket under the table. After the joint was broken loose, I was able to pry it loose using a putty knife and a small pry bar. I repeated the process on the left side of the table, first of all removing the handle, and then removing the lead screw bracket, as was done previously. Once again, I used the small rubber mallet to break the lead screw bracket away from the table. The main table in the mill is quite heavy, probably close to 100 pounds, which would be difficult for me to remove and even more difficult to align and reinstall later. What I found on Amazon was a small jack, which was designed for working on motorcycles. I was able to adjust the jack to the exact height of the table and then slide the table off and onto the jack table surface. This worked quite well. I also removed the gibs. Later, when I reinstalled the table, it was easy to align the table with the saddle, reinstall the gibs, and push the table onto the saddle. Next, I removed the Y-axis handle. I then removed the lead screw bracket. However, breaking the lead screw bracket away from the main base was more difficult because I couldn't get behind it to knock it loose. So this took a little bit of work to break that loose. There are 2 cap screws attaching the saddle to the Y lead screw. I loosen and remove these 2 screws and then completely remove the saddle from the base. I later removed the other lead screw from the saddle offline. I then removed the Y lead screw by just turning it till it came totally loose and out of the base. Next, I started the removal process of the Z-axis. I first of all tighten the 2 gibs on the Z-axis, which locks the head in place. I then loosen the 3 bolts under the head to enable the head to be tilted 90 degrees. In doing this, it actually slipped on me and went beyond 90 degrees. I use a piece of plywood scrap to hold the head in a 90 degree position, and then I retighten the 3 bolts to hold it in place. Tilting the head 90 degrees exposes the 2 hex head screws that attach the head to the lead screw. I then loosen and remove these 2 screws. I then remove the Z-axis handle on the right side of the column. I then remove the 4 bolts holding the bearing flange to the column and remove the flange and the associated gear underneath. Next, I loosen and remove the 4 bolts holding the cap on top of the column. The lead screw assembly cannot be removed from the column without first removing the lead screw nut. I pull the lead screw up to expose the bolts holding the lead screw nut in place. I then remove these bolts and remove the lead screw and lead screw bolt from the column. This completes the disassembly of the PM-30MV. Okay, installing the Y-axis, I could not install it from the top. It just wouldn't fit. So I actually had to move it to another table here so I could tilt it 90 degrees, and I fed it in this way, and it just fits. I got to move the ball screw all the way to the bottom. This thing is heavy. That was a job getting it off of there. Probably going to be getting it back onto the plate. At least I got it in. Next, I installed the servo mount to the base, attaching it to the ball screw and then screwing it into the base of the system. Two hex head bolts are used to mount the servo motor mount to the base of the mill. After I attached the mount to the base, I then checked for the proper movement of this Y-axis component. And what I discovered is the casting was very, very rough on the left side, and it was actually scraping the double ball screw. So I needed to do some grinding on that left side. It was apparently just like a casting error in making the base, because it's very, very rough. And I tried first of all filing some off, but it was too much even for filing. I needed to grind some off with the grinder. So that was the next step, grinding the side. So I disassembled the system once again. Well, I just did a bunch of grinding on this side using a number of tools. I had a air-powered grinding tool I was using, a sanding grinding tool, a Dremel tool, and even this grinding tool. So I'm using all 4 of these to grind this away to try and get into various places. I actually had to reassemble and grind more off several times before I finally got the clearance I needed on the system. It clears, but it's really close. I think I'm going to take a little bit more off. Here I'm showing using my grinder to grind some additional clearance for the grease stuff on the double ball screws. Okay, I think I have enough clearance now, so let me go and reinstall it. This was my first major problem in converting this system to a CNC operation, and reinstalling this Y-axis ball screw, it took quite a bit of time. This was probably the 4th time I had to disassemble and regrind that edge on the base before I got it to the position I wanted. So once again, I reinstalled the ball screw with the double nuts, and then reattached the servo mount, attaching it with screws to the base, and then doing a final check to check the clearance. So now the clearance is good, both the clearance on the side for the double ball screw and also the grease fitting or oil fitting on the side, all cleared quite nicely. I returned the mill to the upright position. It was too heavy for me to lift. I actually had to use an engine hoist to put it to the upright position, and I moved it back in place on the table. And so next I'll be installing the Z-axis ball screw. I decided to do the Z next. Put it back on the table and tilt it back upright. When I tried to install the Z-axis with the lead screw nut, once again it wouldn't go in. So we're going to have to put the lead screw nut in first, hold it in place, and then try and attach the two together internally. I didn't record exactly how I did it, but what I did is I took the lead screw nut and I put the two screws in it, and then I used a rubber band to hold it in place inside the column. And then I took the screw from the top and screwed it into the lead screw nut, and then lowered it down till it eventually fit. But that worked pretty well getting it in place. And then I raised it up so I could tighten the internal screws to hold it in place. I then removed the two nuts from the lead screw that I had used to hold it in place with rubber bands, and then lowered it until it lined up with the screw holes in the headstock. After the holes in the headstock were properly aligned, I then inserted the two screws to attach the headstock to the ball screw lead screw nut. I then attached the servo mount to the top of the column using the 4 bolts supplied with the system, and then tighten them in place, double checking alignment, making sure everything was nice and square and flat, and that everything moved smoothly and evenly. In doing the installation of this PM-30 mill, the most difficult part was the Y-axis because of the bad edge on the base, and then getting the Z-axis took quite a bit of time too because of the lead screw nut needing to be put in separately before I put the screw in. But both are easy to do. I was able to do both quite nicely. This installation did take me much longer than I anticipated, and unfortunately at this point the video went blank because the battery ran out on the camera. So I wasn't able to show the remainder of the installation because I was just consumed with the installation of the system to date, and just missed the battery going dead. So I'll explain in a little bit exactly what I did to finish the installation. The CNC conversion of my Precision Matthews PM-30MV mill is complete. Unfortunately, the batteries died on both of my cameras as I was getting near the completion of the installation. And both batteries went dead at the exact same time. But they've been running for over 3 hours at that point, because this only took much longer than I thought it would take. So let me describe what I did to finish the assembly of the system. The most difficult part of the problem was with the base because of the excess material on the casting I had to grind off. That took quite a while. And then installing the Z-axis was a little bit of a problem, getting the screw into the column here. And I actually had to do it in 2 steps as I showed in the video. The assembly of the X-axis actually went much more smoothly than I thought it would go. I've seen people use 2 different ways to grind out the saddle to make room for the X-axis ball screw. Some people have actually ground it out with a hand grinder, and some other people have actually used a milling machine to grind it out. I ended up using this grinder, the same grinder I used to grind out my excess material on the base. And that went pretty smoothly. It only took me a few minutes to grind out the clearance for this ball screws, double ball screws on the X-axis screw. And so I ground that out, made the clearance for the ball screw, and then attached the screw system to the saddle. The next issue was installing the table, and this table is quite heavy. And I don't think I could have done it myself without this motorcycle jack. This worked quite nicely because I was able to adjust the table to the exact height, of the saddle, and then slide it on. Because this table is quite heavy, and I would have been able to do it myself without the use of that jack. So that worked quite nicely. And so what I did is I adjusted the table to get the correct alignment so it matched with the saddle. I slid it on and inserted the gibs, and then moved it the whole way in, and then attached it by screwing it underneath to the ball screw assembly. So that went quite nicely. So after that, I attached the servo motors. Just screwed all 3 servo motors onto the mounts, attached to the couplers, and tightened the screws on the couplers. And at that point, the system was fully assembled and ready to start testing. I didn't see a lot of videos on YouTube as far as doing this type of installation with the CNC conversion kit. But the one thing I did find on the web was on the Heavy Metals website. They have a series of pictures showing the conversion, and this is actually quite helpful. So you might want to check this out if you need some additional help with the installation. So after the system was installed, I did go to the computer and use the DMM software to auto-tune the 3 servo motors. So I auto-tuned all 3 of those using the software, and then I proceeded to do some testing. And the X and Y system worked very well. They worked smoothly, and there's no issues, and everything seemed to be right on. But then I went to the Z-axis, and I was having problems. I was seeing skipping, and I was seeing skipping and going up. When the system went down, when the head went down, no issues. It went very smoothly. But going up, I could see some hesitation and some slipping. And so I contacted both Dave at Arizona CNC and Stephen at DMM Technologies to get their input on what the problem might be. So first of all, Stephen at DMM Technologies suggested that because of the weight of the head, I may have to manually tune the servo motors. So I did that. I went to the DMM software. I did a manual tune on the servo motor, and that seemed to improve a little bit, but I was still getting a little bit of hesitation. I talked to Dave at Arizona CNC, and he recommended disassembling the head, checking for alignment, making sure everything was square. So I did that. I took it apart, disassembled it. Everything seemed to be square. Everything seemed to be aligned and freely moving. But in doing that, I noticed a gap in this connector between the servo motors and the mount. And so I loosened the screws on this, and in doing so, I noticed one of the screws wasn't really tight. It was tight, but not real tight. So I closed this up to make it nice and tight, and I retightened these screws very tightly, and then I did the additional testing. Everything was fine. So I think my problem was just a loose screw on this connector. I think that's all the problem that there was. After everything was up and running, I did encounter one additional problem. The system was working fine, except when the system was standing still, I was getting a slight hum or vibration in my Z-axis stepper motor. So once again, I contacted Stephen at DMM Technologies, and he suggested that maybe in doing the manual tune, I set my gains too high. So I went back to the computer and the manual tune for the Z-axis, reduced the gains a slight amount, and that resolved the problem. The hum went away. So the system's working perfect now. So a number of problems I encountered, which I described in this video. I hope you found those helpful, and if you encountered the same issues, maybe it'll help you resolve them going forward. But overall, the system installation went quite well. And once again, I do want to thank both Dave at Arizona CNC and Stephen at DMM Technologies. Both were very helpful in resolving my issues. So after the servo motors were all tuned and everything was operating properly, I did some additional testing to check the total operation of the system, and it worked quite nicely. So finally, I readjusted the head to get it perfectly perpendicular, and then I trimmed the system to make sure it was all square, and that all worked fine. And then I added limit switches on the X, Y, and Z, so they're all here. I have the limit switches here underneath this angle iron, which I put under to protect them to keep the metal chips from going onto the limit switches, and I added one over here on the Z column also. I also built this enclosure to enclose the system so I don't get chips all over the house. Because the system is in my base of my house and I don't want to get these chips tracked throughout the house. So this works pretty nice. I'm working on the doors next to get this totally enclosed. Well, I thought I was all done setting this system up, but then I went and made my first project. And when I measured the finished project shown here, the dimensions are off by 1.5% in both the X and the Y dimensions, and probably the Z also. So obviously the pitch on my screws is incorrect, and I need to change that in the wizard. So let me start the wizard up, and we'll go in and change those dimensions. So I go into the wizard, and I click on the configuration under axis, and then look at the overall turns ratio. And this number for all three axes were originally set to 5. So I increased it to 5.08, which is about 1.5% larger. And I change it on all three of them now, and I'll go and I'll check the calibration on the mill. So I saved these new settings to the system, and then I need to close the wizard and reboot both the computer and the mill. So I shut down the software, exit CNC 12, and then also turn off the controller. I then rebooted the system and set all the axes back to 0. So I'll be starting with X in the 0 position to do this calibration. So let me go over next to the mill and show you how I calibrate it. I'm starting off with the X-axis on the computer set to 0, and I put a small pointer in the chuck on my mill, and I brought this pointer down, and I also then taped a 24-inch ruler to my tabletop, setting the 0 point right on the pointer and right on 0 on my system. I'm then going to crank the software over to 21 inches and see where the pointer ends up on my ruler. Before I reset the screw pitch in the wizard, the pointer went out to about 20.7, 20.6. So now we'll see where it goes out. So I set the software to take it out to 21. This was actually the second time I did this. The first time I set the pitch to 5.05, and it wasn't quite enough. And it's exactly on 21. Calibration is right on. So let me next go and do the Z-axis, check that also. So I put a small ruler on the table, and I moved the Y-axis back to its limit so it's close to the edge of the table. It's pretty hard to adjust it to 0, so I put the pointer on the 1-inch mark on the ruler. And set my scale on the computer to 0 at that point. Then I moved it 5 inches and checked the calibration. And the pointer went right to 6, which is 5 inches. So the calibration in the Y-axis is also correct. So that completes the calibration of the mill. Both X, Y, and Z were calibrated, adjusted from a pitch of 5 to a pitch of 5.08 in the wizard. When I reran my project, the dimensions were right on, and I'll be showing this project in a future video. So in conclusion, a few comments on the installation. I would recommend, if at all possible, having 2 people to help with the installation. If you had to move this column and all, it is heavy, and it really is a 2-man job. I was able to do it myself, but I needed one of these jacks, these engine jacks or engine hoist to lift the column up, and also this motorcycle adjustment table worked quite nicely for putting the table on, because for one person to lift that table, it's pretty heavy. Other than that, it went pretty smoothly. The grinding required on the base, which I had not expected. It was something totally different I'd never seen before. But the grinding on the saddle for the ball screws, actually that was no problem at all. But it went pretty smoothly. Total assembly time was probably close to 4 hours by the time I was done. It was a good half day. Actually took a little more by shooting some of the video, but about 4 hours to do the total installation. But I mentioned before, a lot of that time was running around finding tools, because I got tools all over the shop, and having never done this before, the tool I wanted, of course, was in the other part of the shop. I had to run and get it, so it took some time. But overall, I'm quite happy with the system, and now I'm ready to start doing some machining of some parts. Once again, thank you for watching this video. If you have any questions, comments, or concerns, please give me a call or drop me an email. Thank you.